Hi everyone, so today we're going to talk about blood glucose, but before we talk about what blood glucose is, what is glucose? Well, glucose is a carbohydrate, and more specifically is a monosaccharide, and again, a monosaccharide is like the simplest unit of a carbohydrate, so it's like very simple type of sugar. And the thing about glucose is that it's like the simplest form of sugar that your body can use, and it's easily metabolized and turned into ATP, that which is a form of energy that your enzymes love to use to drive their reactions. So with the glycogen, now the thing is that what if your body has or cells have too much glucose? Then what your cells can do is store it as glycogen. So glycogen is when they take all these glucose molecules and link them together and store them for later. That way, if you need glucose later on, but you didn't eat anything, and you need to use up your energy stores, then your body can take glycogen, break it apart, and then get glucose back in its original form. Now here we see the different ways of looking at glucose, but they all have the same chemical formula. You see carbon, hydrogen, and oxygen. Now this straight chain form and ring form, and if you just take this atom right here and bond right here, this is how you flip between the straight chain form and ring form. Now if you're taking my class, I expect you to memorize these organic chemical structures right here, but the thing we want to appreciate is like there's 6 carbons that form the central backbone of glucose. And this is why you often see glucose represented as a hexagon, because it's representing this kind of ring form here. And this is just a 3D structure showing you the same chemical formula, but in the ring form. Now, why is glucose important is because your cells can easily use it. I mean, your cells have an easy time taking glucose, and even if there's no oxygen, it can convert glucose into ATP, which is needed by a lot of cellular processes that require energy. But if you get oxygen in the equation, your cells can actually reap more ATP from that, but more in a future chapter. Now, glucose, how do you get it? Well, you can easily eat glucose. Glucose is a sugar, and there's sugar sources everywhere. And another form of polysaccharide of glucose is starch. So starch you find in a lot of plants. So your digestive system can take the starch, break it down, and then you can get glucose molecules in simple monosaccharide carbohydrates. And the thing is that, say you don't have food around, so your body, in like starvation or fasting conditions, it can actually take different organic chemicals and compounds from your body and take their carbons and then stitch it back together to make that 6-carbon glucose structure that we see over here. Now, glucose sugar dissolves in water very easily, and so does glucose. So glucose is water soluble, very hydrophilic, and your blood is the liquid part is mostly water. So glucose has an easy time dissolving in blood. And the thing is that when you eat glucose or anything starch or any source of glucose, it gets broken down by your digestive system, absorbed in your intestines, and then it enters the blood vessels leading from the intestines and then to the rest of the body. So your blood is the main way of transporting the glucose you eat and make in your body. So what is blood glucose? So blood glucose is referring to how much glucose you have in your blood. Also, sometimes it's called plasma glucose because plasma is the liquid portion of your blood. Also, nursing and a lot of clinicians like to say blood sugar. And what sugar? Glucose. Now, the thing is that, how do you measure it? Well, it's the concentration of glucose in blood. Basically, how much glucose do you have in terms of mass per volume of blood? Now, in the United States, we use milligrams per deciliter. So this is whenever they say a number, that's the unit you'll use in the United States. Now, you might be familiar with milligrams. So milligrams, 1,000 milligrams equals a gram. But a deciliter might be a new unit. So a deciliter is 1/10 of a liter. It's not 10 liters, 1/10, 1 over 10. So that means 10 deciliters equals 1 liter, or 0.1 liter equals 1 deciliter. So whichever works out in your mind. Now, euglycemia refers to a normal range. It's not just one value, but you have a normal range and an upper and lower limit where you're considered to have normal blood glucose. Now, this medical term for that is called euglycemia, as you see here. And then why is it important to have a normal blood glucose? Because if your blood glucose gets too low, then how is your body and tissues and cells going to get its energy? It can't. So then the lower you go, the more severe the symptoms. And if you dip below here, it's like you can in a coma, and if even lower, then you can die. Now, on the other end, then you have abnormally high blood glucose. You don't see in this chart right here, but if you get sometimes like as you approach the hundreds, yeah, that's when it start to get high blood glucose. And anecdotally, I've heard from some of the med students on clerkships, they've seen in the thousands, and I'm like, whoa, that's pretty amazing. But the thing is that isn't, well, not amazing in terms of like health, because if you have a high blood glucose in that extreme, that can easily put you in coma and kill you as well. So too low, bad news; too high, bad news, and you can die either way. That's why maintaining a normal blood glucose and homeostasis in your blood glucose concentration is very important. Now, what is the normal range? And this is the one, well we have to add a little condition. It has to be the normal fasting range, and this is the normal fasting range of blood glucose. So 70 to 100 mg per deciliter. Now you might be like, wait, this says 110. So this is from the old Martini book we used to use several years back. But this is the more modern and updated value that accepted by many authorities. It's not just me. But the thing is that, again, that deciliter, that 1/10 of a liter, 10 deciliters equals 1 liter. But fasting itself, so if that means you don't eat anything, you don't eat anything and you don't get any calories near from eating or drinking for a given amount of time. Now, some labs, they say you can drink tea or coffee because they don't have calories. Other labs disagree. They say it affects metabolism. Either way, if you're not in doubt, water is good. It's usually okay. I mean, maybe more extreme ones might tell you not even water, but most labs accept water. But it's the tea or coffee I would ask first. But to be safe, water is probably the safest thing. Now, 8 hours, or it's usually more than 8 hours. Some labs or clinics ask for 12 hours, and maybe on the extreme end, even longer than that. But typically you see them, they say, okay, have you eaten or in the past 8 and 12 hours? So that's why whenever you get a blood glucose test, they always ask you, have you eaten anything, or is this a fasting blood glucose test? Now, how can you measure blood glucose? Well, here's one of those example of a home glucometer you can see at home, and this is a little machine. So you don't need to go all the way to the lab and get your veins venipuncture and have a blood sample draw. What you do is there's a little needle inside a little contraption. It does a little click and it stabs you, pinpricks you. It's like maybe it hurts for a little fraction of a second. But then you start bleeding from that, and you typically squeeze out the first drop, and don't measure it, because that first drop is filtering through the layers of skin. So usually that throws off the initial reading a bit. Then the second or third, I mean, sometimes they say take the second, sometimes they say you need to squeeze out 2 drops. But either way, follow the instructions in whatever machine you're using. So then you put a drop of blood on this little strip, and the glucometer reads it through chemical reactions. And again, if you want to know about that, then sometimes they tell you more about the reaction in the manual. But either way, you come up with a number, and this tells you their blood glucose, what concentration. Now, here we have 254. So this person they're definitely above that normal range. They're in hyperglycemia, assuming that this is a fasting blood glucose test. Now, what is a fasting blood glucose test? Again, this is why why do we use this, the 70 to 100, is because those are the values accepted as of 2022. Now, if this changes in the future, please contact me. That means I need to create another updated video. But as of 2022, I think I'm recording this 2024, this is what accepted by the American Diabetes Association and the NIDDK. So the leading authority on health and research in the United States is the National Institutes of Health. The NIDDK is a subdivision called the National Institute of Diabetes and Digestive and Kidney Diseases. So basically, yeah, everything diabetes, they're the authorities on that. So the two authorities, this is what they use, but it's not just those two. Then, so again, this is why I'm crossing out that 110, because that's like an older one you see in older textbooks, but the things that the Martini and OpenStax textbooks still use this value. Now, if you're going to be going to nursing, or if you're going to go into medicine, you have to take the licensing exams. Now, the NCLEX, now I don't know where they got the 64 part. I'm trying to research that, because I mean, okay, that's interesting they lowered it to that. But what you see, this is from the nursing.org or nurse.org, and they used 100 mg per deciliter. They don't use the 110. And here's from the MBME who does the USMLE licensing exam for doctors, and they use the 70 to 100 mg per deciliter. So 70 to 100 mg per deciliter is pretty widely accepted among the clinicians and authorities. So that 110 is kind of an older number. Now, if you're international and not in the US, or you're planning to go abroad and become a nurse or doctor or health professional, so some countries use a different unit. So they use millimoles per liter instead of mgs per deciliter. And as you can see, the range, the normal range the numbers are much smaller. So things like countries like the United Kingdom, Canada, Australia, New Zealand, they use millimoles per liter. I think Canada used to use both, but I think they migrated towards millimoles per liter. Like from the source I saw, they said that those glucometers and devices, they were more accurate with millimoles per liter versus mgs per deciliter. But I'm just letting you know that not everybody uses the same unit, especially if you're reading international papers. And it's because if someone had 5.5 mg per deciliter, they would be they would be in coma, if not dead already. So this is way lower. So again, just letting you know, if you see single digits, it's probably using millimoles per liter, or otherwise you have a real bad crisis there. But if you're using those international units, that's the normal range. We see less than 5.5, and diabetes would be above 7 millimoles per liter in terms of like fasting blood glucose. Now, why do you need to fast? Well, if you have a random blood glucose test, and what is a random blood glucose test? It's that basically you're measuring blood glucose, but no fasting. So you're taking it sometime during the day. It doesn't matter whether you ate or not. Now, this is an example chart right here. We see that this person took blood samples and measured their blood glucose throughout. I guess they had to get up at every single hour during this day. But what we see is that it changes. It dips all the way below here, like maybe around 140-ish, and all the way up here towards like the 270, at least in this person right here. And yeah, this person right here, like maybe it does spikes more around 160, so narrow range. But either way, we see these huge spikes right here. It goes up and down. Now, with each of these spikes right here, what do we see? Well, just before that, we see these letters B, L, and D. What do you think that means? Maybe breakfast, lunch, and dinner. So what happens is that you're eating a meal, and after you eat a meal, all those carbs and nutrients get into your digestive system, and then your digestive system absorbs it in the intestines, and that ends up in your blood. So this is why every time you eat calories, and especially sugar, your blood glucose will spike. But thanks to the effects of hormones like insulin, this brings it back down to normal. Now, this is why if you take it at any different time, you can get a big wide range, and this is why they ask you for, in terms of measuring your blood glucose, to fast, because again, if you're not eating anything, this is trying to kind of measure what your baseline is in your body. If you're not eating a meal and your body just trying to maintain its own normal level or homeostasis of blood glucose levels. Now, what's the normal range, or what's the normal value of a random blood glucose test? Well, I'll present a few. So here are some authorities I saw. So here we have CDC and ADA. They say anything less than 200 mg per deciliter. And then over here with Medscape, and they cite these, and this is yet another CDC source, and they say less than 140 mg per deciliter, so there's inconsistency here. And here's from diabetes.org, and another inconsistency. So they say this is more strict than the other sources we see here. Now here we have UCSF, and UCSF is a pretty important research college or university, and they do a lot of diabetes research, and they make it even stricter. And then the Endocrine Society, they're a leader of like medical research in everything endocrine, and especially diabetes, and they say make it even stricter at 100. So what I'm getting at here is that there's no universal consensus on this random blood glucose test. So this is why I won't typically ask you for, if you're taking my class, to know which is the normal range for a random blood glucose. But fasting blood glucose, that's the one that's widely accepted and standardized at around 70 to 100.